Okay, we've got the 9MAO, the statistics paper, paper 3, October 2021, question 5, normal distribution question. There are all sorts in here. There's just standard questions, a bit of conditional probability, and a hypothesis testing part at the end. There we go. Heights of females from a country are normally distributed with a mean of 166.5 and a standard deviation of 6.1. When we write that 6.1 squared, that's the variance. 1% of females are shorter than K, so K is over here, and that area is 0.01. Got to find the value of K. Menu 7.3, the inverse normal function, because we're working out what the K is when we know the area, which we put in first, and then the standard deviation, and then the mean, and gives us a K of 152.3. You could use the Z values table from the formula book, but these Z values are all to do with areas to the right. So this one's saying, for instance, if you're 1.28 standard deviation above the mean, and that area will be 0.1. We always deal with areas to the left on the calculator, so these should all be negative, really. But what can I tell you? The exam board hates you. So if you want an area to the left of 0.9, that would have a positive Z value 1.28. The one we're looking at here, we've got an area to the left of 0.1, so we've got a Z value minus 2.32. Most people use this version of the formula. We used to use it a lot before we had the calculator, because we normally know the X and want to work out the Z value. These days, we're probably going to be using the Z value, so I think it's probably better. I prefer to use this one. It's the same thing, really, to multiply by the sigma, add the mu, and then we can stick it in. Then the X is the K that we're looking for. Mu is 166.5. The Z is that minus 2.32, and the sigma 6.1, and you get 152.3 like we had before. Then he said, find the proportion of females in the country with heights between 150 and 175. 150 is down there below the mean, 175 above it. We want this area. So we've got menu 7.2, just normal steely, lower 150, upper 175, sigma, and mu. You should have still having the calculator from before. And then that area between 150 and 175, 0.915, three significant figures. Female from this country is chosen at random. From those with heights between 150 and 175, we're going to find the probability that her height is more than 160. So really, we're sort of trying to find out what fraction of the sort of the green shaded bit is above 160. So there we go, the yellow bit. What fraction is the yellow, goldy, orangey bit, and what fraction is that out of the green one? So it's a conditional probability, really. What's the chance we're more than 160, given that we're in between 150 and 175? You get this multiplication rule in the formula book for probability. The intersection is that conditional one time by the probability of A. We can rearrange it. B given A is the intersection over the A. My A here is this one, and that's the B. So the A is going to go on the bottom, and on the top it's A and B, so it needs to be greater than 160 and in between 150 and 175, so it's 160 to 175. We've already worked out the bottom line, and the top line is about 0.7749. Use a bit more accurate value than the 0.915 though, because we were using in the working. You get about 0.847. Last part is a hypothesis testing question. Heights of females from a different country are normally distributed with a standard deviation of 7.4. Mia believes the mean height of the females is less than 166.5. We're going to assume it's 166.5 for now, and see if we find anything that contradicts that. Mia takes a random sample of 50 females from this country and finds the mean of the sample is 164.6. That is below 166.5, but is it low enough for us to question whether the mean is actually 166.5? This is what it tells you in the formula book, and this is suggesting that for the sample mean, the standard deviation is the standard deviation of the whole population divided by the square root of the sample size. N observations from this population A new standard deviation is the old standard deviation. The standard deviation of the population divided by the square root of n. And that's really because if we took a sample like this, well, the mean of the sample is going to be in the middle of the whole sample. So it's going to be much closer to the mean of the population, which is at 166.5. So it's going to have a thinner sort of normal distribution like this. Still got a mean of 166.5 though. And like I say, this one's got a standard deviation of 7.4 over root 50, or a variance of 7.4 squared over 50. So here's the x, and this is the x bar. That's got a sigma of 7.4, and this has got a sigma of 7.4 over root 50. I'm going to carry out a Subel test to assess their belief. We're going to state the hypotheses clearly, and it's pretty standard. The H0 is the mu is 166.5, which would mean me is wrong. There's nothing unusual that's happened. And the alternative hypothesis, mu is actually less than 166.5, as Mia thinks. We're going to use a 5% level of significance. So really we're going to find out what the chance of being less than 164.6 is. And if it's less than 5%, then the value of the sample mean that we got is too low, too weird, too far away from the population mean for us to accept it. And when we work out the chance of x bar being less than 164.6, we do get a value of less than 5%. Remember, that's using that standard deviation and that mean. So we need an upper of that, lower of minus 16 million, mean of 166.5, and the standard deviation of 7.4 root 50. So it's less than 5%. So it is significant. We're going to reject H0. There's evidence to support Mia's belief.